All right, ladies and gentlemen, we got the chapter 13 examples. We'll start with number 1. We're going to calculate the molality of each of these two solutions. So the first one, 3.75 molar potassium chloride, right? And it gives you a density of 1.09 grams per cubic meter, grams per milliliter, excuse me. And then a 36.1% mass sodium bromide. All right, let's start with A. Potassium chloride, of course, is KCl. So we have 3.75 moles of KCl. That's a horrible K. Let's try that again. Per 1 liter of solution. And we need to transfer that into moles of KCl per kilogram of H2O. All right. Well, let's find the mass of 1 liter, all right? Because we don't have an amount. Neither one of these have amounts, so there's no amounts here. No amounts. So we're going to start with a mass of 1 liter. We're going to assume 1 liter. So if I have 1 liter of solution, right, we know our density is for every what? 1 liter is 1,000 milliliters. And 1 milliliter of solution is 1.09 grams. So my 1 liter is 1,090 grams of solution. Now, we got to figure out the mass of water. I got the mass of solution. I need the mass of water. Well, we know in my 1 liter, we have 3.75 moles of KCl. So if we take our 3.75 moles of KCl, we know what? That 1 mole of potassium chloride, potassium is 39.1 plus chlorine 35.45. I got 74.55. Right? Did I do that right? Yeah. So 74.55 grams of KCl. And so if I do that, 3.75 times our 74.55, I get 279.5625 grams of KCl in my solution. All right, so what do we do with that? Well, first of all, I have 3 sig figs, so this becomes 280 grams of KCl. And I know my solution is 1,090 grams. If we subtract the 280 grams of KCl, that'll give us what? So 1090 minus 280, 810 grams of H2O, which is the same thing as 0.810 kilograms. So now we can go to the molality. So the molality would equal our 3.75 moles of KCl and our 0.810 kilograms of water. So 3.75 divided by 0.81. And I get 4.63. And so there is the answer I have to A. Fantastic. Now B. How are we going to do B? Well, B, we know we have 36.1% mass NABR. So that means I would have 36.1 grams of NABR per 100 grams of solution. Or $36.1 grams of NABR. And if I take 36.1, I take 100 minus our 36.1, right? Because the two substances in the solution would be sodium bromide and water. That would give me 63.9 grams of H2O. Well, I can convert that. And so we got, let's try this out. We take our 36.1 grams of sodium bromide and our 63.9 grams of water. And let's see how we can do here. I can convert grams to moles. So we know that sodium is 22.99. And we know that bromine is 79.9. So that gives me 102.89. Of sodium bromide is 1 mole. Now we're in moles of sodium bromide. And then we know 1,000 grams of water is 1 kilogram of water. And that's it. So I take our 36.1 times your 1,000, divide 63.9 divided by 102.89. And I get 5.49076 90438. And we have 3 sig figs, so 5.49 mol sodium bromide. And that is part B. Well, I hope number 1 makes sense. We'll see you next one.